Hello Year 8 mathematicians. Good morning. Just set the video up. We've been looking at prime numbers, and I want to show you something today which will take several videos to deal with, and I'll do it a piece at a time. I want to look at the problem of adding together fractions, and we'll start by doing something nice and simple. If we have 2/7 plus 3/7, I think you all know how to do that. That's nice and easy. Sevenths and sevenths, we can add them together. The denominator, the number on the bottom of the fraction, stays the same, sevenths. We don't change that. It's important to understand that. The 7 and the 7 don't add up. They just stay the same. This is like saying 2 oranges plus 3 oranges equals 7 equals some number of oranges. The 7 stays the same. The denominator doesn't change. And the 2 and the 3 add up, because that's 2 plus 3 equals 5/7. And you can check that with a calculator by seeing what the value is of 2/7, seeing what the value is of 3/7, adding them up and making sure that that equals 5/7. And the important thing about this is that all through this calculation we have the same denominator. And I think you know that, and I think you know how to deal with a problem. So if we look at a problem like, say, adding 3/5 plus 3/7, for example, we can't add those fractions up immediately because fifths and sevenths are different units, different denominators. So we have to put this on the same denominator. And one way to deal with the denominator is we need to find a common denominator. And one way to get a common denominator is to just take that number and multiply it by this number and say that the common denominator equals 5 times 7 equals 35. And in order to get this fraction with a denominator of 35, we multiply top and bottom by 7, obviously, because we've got a 5 on the bottom already. We've got a 5 on the denominator. So that becomes equal to 3 times 7 over 5 times 7. Look what we've done to this fraction. It was 3/5. It now becomes 3/5 times 7 on the top times 7 on the bottom. Look, 7 over 7 is 1. So we haven't actually changed this fraction at all. Don't think that we've multiplied this fraction somehow by 7. We haven't. We've multiplied it by 7 on the top, and we've multiplied it by 7 on the bottom, and those 7s could cancel out. We haven't really changed it at all. Plus, now we've got to take on this side, we've got to multiply top and the bottom. Well, we need a denominator of 35. We've already got 7, so we have to multiply top and bottom by 5. So this becomes 3 times 5 on the top, 7 times 5 on the bottom. We haven't changed this at all. This was 3/7. It's still 3/7, but it's 3/7 times 5 over 5, but 5 over 5 is just 1, so it's exactly the same as it was before. We haven't changed these fractions into some different numbers. We've just found a different way of writing them. And now if we evaluate that, 3/7 on the top of this fraction is 21, plus 3/5 on the top of that fraction is 15. This is now divided by 5 times 7 is 35, and this is also 5 times 7 is also 35, and that means that the answer that we get, I could write this 21 over 35, let's do that, plus 15 over 35, which is the same as 21 plus 15 over 35. Notice that the denominator stays the same, and 21 plus 15 is whatever it is, 36 over 35. And that's an improper fraction. We can simplify that, of course. We can go to 1 plus 1/35. And you can check with a calculator that that has a value. I haven't got a calculator with me. It's going to be 1.0 something, 1.02 0.07 or something like that. It's approximately equal to 1.027. I do that with a biological calculator. Everything's still in the frame of view? Yes, it is. And you can check that if you take this fraction and add them up, that you get that answer. Approximately equal to 1.027. So something like that. And the thing that we did to get there, just to remind you, is that we had a fraction where the denominator was in fifths and a fraction where the denominator was in sevenths. The 5 and the 7, we multiplied them together to produce a common denominator. All right, well, that's the first stage in this video, and we'll carry on from there.